8.4 tangents to a circle. So a tangent line, it intersects the circle exactly at one point, and it's called the point of tangency. Now, M in this one is the tangent line, and B is the point of tangency. Now, it's not one specific line that this is going to happen with. I could have something like maybe here where it intersects here, or here. It's just the point of tangency and then that line that's kind of going through it. So you technically have infinite tangent lines to any circle. And then we're going to talk about a theorem that involves the tangent lines. So our theorem states that if a line is tangent to a given circle, so if M is tangent to circle A, then the tangent line is perpendicular to the radius at the point of tangency. Now that's kind of the important part, is it's where this line meets the circle. I can draw a radius to that point and have it be 90 degrees. It has to go through that point. So I can't have something like this and then have a line and then say, well, the radius is perpendicular to that line. It has to go through that point of tangency. So that's kind of the key there. The converse is true. So if the line is perpendicular, so if this line is perpendicular, then it's a tangent line. So if it's a tangent line, the radius can be perpendicular, or the radius is perpendicular at that point. If it's perpendicular, then that means it's a tangent line. That's what that's meaning. So we're going to do some examples. I'm going to say, given that line AB is tangent to circle C, find the length of AC. So AC is that one right there. So what we're going to do is, I know that because of the theorem we just talked about, that if AB is tangent to the circle, this is my point of tangency. This is a 90-degree angle. Well, if that's a 90-degree angle, I have a right triangle. I'm going to redraw the triangle. Where this is 8 centimeters, this is 15 centimeters. So what I'm missing is the hypotenuse. And that is what we're trying to find. That's my AC right there. So I'm going to do Pythagorean theorem. So side squared plus side squared equals missing side squared. Keep in mind with the Pythagorean theorem, the hypotenuse has to be by itself. Remember, it's too big to be mixing with the other sides. And the hypotenuse is the one not touching or across from the 90 degree angle. Okay, well, when I work through this, I'm going to go ahead and get my calculator. See if you can see that. So 15 squared plus 8 squared is 289. And then to undo a squared, I take the square root. So let's see if we can simplify this. So the square root of 289 is 17. That worked out nicely. So the length from A to C is 17 centimeters. Then we're going to determine if line AB is tangent to the circle. So on this one, it's giving me these side lengths. I have a 9, a 15, and a 17. If this line is tangent, I don't know that it's tangent. If it's tangent, this angle is going to be a 90-degree angle. So it might be a 90-degree angle, it might not. Now, to show that it is a 90-degree angle, the Pythagorean theorem is going to have to be true. This would be my hypotenuse. So I'm going to take 9 squared plus 15 squared should equal 17 squared. If it does, then this is a right triangle, therefore that line is tangent. If it doesn't, then that means that that's not a 90-degree angle, and that means it's not a tangent line. So I'm going to do 9 squared plus 15 squared. That's 306. And then 17 squared is 289. Is that a true statement? Does 306 equal 289? No. So what that means is this is not a right angle. So AB is not tangent to circle C. Okay, let's see if we can figure out some other things. Okay, so this one, given that line AB is tangent to circle C. Well, if AB is tangent to that circle, then I know this is a right angle. Find the length of AD. So what I'm trying to find is the hypotenuse of this triangle. Well, if this is 90 degrees, this is 45. And we need to remember that the sum of the interior angles of a triangle is 180. So I'm going to subtract the 90, subtract the 45, and that should give me my 45, 45, 90 triangle. Now, if you have gone through special right triangles, you'll know the relationship between these. If you haven't, you should still know that if this is 10 centimeters right here, and that's across from the 45-degree angle, it's opening up to get 10 centimeters. So this one has to open up the same amount. So that is also 10 centimeters. Well, if I don't know special right triangles, I can still do the Pythagorean theorem here. So I get 10 squared plus 10 squared equals the missing side squared. So then I get 100 plus 100 is 200. Take the square root of both sides. Okay, when I use the calculator on that, it isn't anything nice. I need to simplify this because this is not an exact answer. My calculator is rounding this. So what I'm going to do is I'm going to see if there's a perfect square that 200 can divide by. So I'm going to try 100 because that is a perfect square and it works. So I'm going to split this into 100 times 2 and then take the square root of both pieces. Well, the square root of 100 is 10. The square root of 2 is just square root of 2. That's the part that I can't really simplify. And then the units here are centimeters. And that's the length of AD. Okay, the next one, given line AB is tangent to the circle, so this is a 90-degree angle, find the length of AC. Well, in this one, I need to know some of the basic trig functions. So what I'm going to do is look at the triangle that I have. So I have a right triangle, 9 centimeters, and a 55-degree angle. And I'm trying to find AC, which is the hypotenuse of this triangle. So what I'm going to do is say, okay, well, this is my angle. That is the theta, is what we were calling it. Well, I know that in this triangle, in reference to theta, this is the opposite side, this is the hypotenuse, and this is the adjacent side. So what trig functions, or what sides do I want to involve? The opposite, because I have that length, and hypotenuse, because I'm finding that side. What trig function uses opposite and hypotenuse? So, TOA. Opposite and hypotenuse, that's your SO. So what I'm going to do is say sine of an angle is opposite over hypotenuse. Well, I know my angle is 55. I have the opposite side is 9. The hypotenuse is my missing side. Now, I don't get to just divide by 9 or multiply by 9 on this one, because what I'm trying to find is in the denominator. So what I'm going to do is multiply by m on both sides. M divided by m is just 1, and 1 times 9. And then on this one I have the m times sine of 55. Now remember, sine of 55 is a number itself. It's just not one that we can actually write out as an exact answer. So what I'm going to do is it's being multiplied. So I'm going to divide by sine of 55. So the missing side is going to be equal to 9 divided by sine of 55. And that's what we're going to type into the calculator. Now I'm in the wrong mode for my calculator because this says radians up here. It needs to say degrees. So I'm going to hit mode, go to where it says radian degrees. So radian degrees, hit enter, and now it says degrees. So I'm going to hit second mode because that's going to quit to the main menu. And I'm going to type this in, 9 divided by sine of 55. So m is roughly 10.99 centimeters, and it didn't tell me where to round. So you can have that as your answer, or you could round it to 11 centimeters. But you do need to know basic trig functions for that type of problem. Okay, this next one, solve for x, assume that all lines that appear tangent are tangent. So this says that in my triangle, this line appears to be tangent, it is tangent. Now my triangle is weird because it's saying this side has a length of x, this side has a length of 18, but this side is being split. So this piece right here is 12, this is x. Why would they be the same length? Well, in both cases, they're the radius of the circle, so they're going to be equivalent. So when I'm working with a right triangle here, I'm going to redraw this triangle. I have this side was x, this side is 18. This hypotenuse, I'm going to have to take the whole length. So I have 12 plus x. You can write that as x plus 12. And then I'm going to solve for x. This way I'm going to find the radius of the circle. So I'm going to write out the Pythagorean theorem. So it's side squared plus side squared. And that's going to equal, see if I can move it into the light a little bit more. That's going to equal the hypotenuse squared. We have to be careful. It's squaring the entire side, not the individual pieces. So I need to actually write that out. So I'm not doing anything with my x squared plus 18 squared yet. But this one, I get 12 plus x plus, times 12 plus x. Because I have to multiply them together, that's what the squared is saying. So 12 times 12 is 144. 12 times x is 12x. X times 12 is 12x. And x times x is x squared. Now, if you struggle with solving equations, there's a lot going on in this one. So what I'm going to do is draw a line so that I can keep everything straight. And I'm going to combine like terms. Do I have another x squared on this side? No. Do I have another number on this side? No. But what I can do is expand, or I can multiply that. So I'm going to take this x squared plus, and then what is 18 squared? 324. And then I have a number and no other numbers. Here I have 12x and 12x. So what is 12 plus 12? 24x. And then I have that x squared piece. Now I have things kind of cleaned up a little bit. So I'm going to try to get my x squareds on the same side. So I'm going to subtract x squared because I don't want it on this side anymore. Whatever I do to one side, I have to do to the other. And I'm going to line up my x squareds. So this is going to be 0, which is what I wanted. 324 equals 144 plus 24x. And x squared minus x squared gives me 0, so that's convenient. Okay, so then I'm going to subtract 144 from both sides, because that's going to get that to go to 0. And I get 180 equals 24x. Divide by 24. Because 24 divided by 24 is just 1, and then I get 1 times x. And then 180 divided by 24 is 7.5. There were no units, so that's my answer. Okay, so if you need to go back through any of those examples, I suggest you do. There's one more thing I want to talk about, but I'm going to make another video for that. So if you need a break, this would be a good time.